Hi guys, welcome back to the channel. In this video we are going to discuss about decoder as demultiplexer and vice versa. That is demultiplexer as decoder. So let's get started. In the previous video of demultiplexer we have already saw the three types of demultiplexer. So there are many types but we have saw mainly three types, that is 1 cross 2 or 1 cross 4 and 1 cross 8. These are very important. So there only in brief we have discussed there the decoder as demultiplexer. So now let's also see once again that how we can implement the demultiplexer with the help of decoder. So if you see the already we have discussed the basics of both decoder and demultiplexer. So if you want the videos of both decoder and demultiplexer, I am giving the videos in the description box. Check it out. So if you consider the decoder has n inputs and 2 power n outputs. So multiplexer has n 2 power n outputs and 1 input and n select lines. You can simply relate n select lines will be gone as 2 power n outputs, and here we have one output, that is I. So here in this also we have n e as enable, so we can compare both of them easily. So let's do how to do conversion. Just first let's start with the 3 cross 8 decoder. So if you observe 3 cross 8 decoder, we have enable line also a b c as 3 variables and total 8 outputs. So this is the truth table from D0 to D7. The total 8 puts already we have know. So let's see how to do that. Now I have changed the input positions to the downwards of the 3 cross 8 decoder, and enable line I have changed the position. Is there any change in the circuit? No. Is there no change in the circuit? Because all the things would be the same, because 3 variable lines are there, 1 enable line is there, all the things would be same, and the circuit truth table would be also be the same. So if you observe clearly, this is the outline of the 1 cross 8 demultiplexer. So unfortunately we have made the 1 cross 8 demultiplexer structure with the help of 3 cross 8 decoder. So change the variables also, then you can also able to observe very clearly this is a 1 cross 8 demultiplexer. So in the same way, if you observe this is the 1 cross 8 demultiplexer. The structure would be the same, the truth table also the same. So I just nothing, the enable line is changed to the input line I. And if you see also ABC select lines here, if you pass ABC as 111, you are going to select the D7 line, that is the same function as demultiplexer. So the output is passed, or the input will be coming from I, that is gone to D7 if ABC is 111. If ABC is 000, the outline means the output would be selected, that is D0. The I would be passed to D0. If you are familiar with the 3 cross 8 decoder circuit diagram, so that in the same way we are going to formulate, but just variable is changing, that is S0, S1, S2 and I. In that ABC is there, that is nothing. Here we have select lines, that there we have the inputs. So if you observe, we have I is connected to all. So if you observe clearly in this circuit also we have saw in the demultiplexer video. So the circuit diagram is just 1 cross 8 demultiplexer. So with the help of that we can implement any of the boolean logic that we want. So we will be going to implement the full adder. So before that we need to understand an important point. So let us take that point, that is to implement n variable boolean function we need demux with n selection lines. So in the multiplexer and demultiplexer both the rules are same, we need to have n select lines. So down also I have shown with the arrows, that is n variables for n select lines. Suppose if you have an example, take in this case only for full adder only we have 3 variables a b c. So the output or the select lines based on 3 selection lines only. For that we need to use 8 cross 1 demultiplexer. Normal also we need to use 8 cross 1 multiplexer for multiplexers. So let's see to how to implement the full adder. So if you see this is the block diagram and truth table of the full adder. I hope you know the full adder. I am giving the video in the description box, check it out if you don't know. So here we have 3 variables, 3 inputs, that is A, B, C in, and 2 outputs, sum and carry. The truth table also represents the same thing. In the decoders video we have seen that. So suppose if you have 3 cross 8 decoder to implement the full adder, if you also see the min terms, that's for sum is 1 2 4 7 and for carry is 3 5 6 7. So according to the min terms that they have joined with the OR gate to represent that sum and carries. So if you observe sum, that is 1 2 4 7, 1 2 4 7 will be connected directly to the OR gate, and for carry 3 5 6 7 is indicated with the blue color, and for the sum it is indicated with the orange color, if you can observe there. So this is the implementation with the help of 3 cross 8 decoder. So we have already discussed how to implement the decoder and demultiplexer. So in this case also the full adder implementation, so we already saw with the help of decoder. For the demultiplexer implementation, just invert the inputs and enable line. Enable line as input line and 3 inputs as the select lines. So that's the representation of 1x8 demultiplex. So remaining all things would be the same for the sum and carry. So for the more understanding purpose, we are going to see the second example with the help of both decoder and demultiplexer implementations. So if you consider the first one, that is even parity checker, that is first one means the decoder with the help of decoder. So that is the even parity checker. So I hope you know the even parity checker. So this means whenever the inputs are odd number of ones, then the output or the parity would be 1. If you consider we have in the min terms, that is M1, M2, M4 and M7. So if you observe the M7 position, that is 1, 1, 1. So we have odd number of ones, that is 3. So then output would be 1. So if you observe 0, 0, 1, that is we have odd number of ones, so output would be 1. So I hope you are understanding. So according to that, we are going to join all the min terms with the OR gate, so that we need to get the output of even parity checker P. So in this also we are going to use the 3x8 decoder, 3 variables ABC and one enable line E. You can also clearly observe this. This is the implementation with the help of 1x8 Demux. So I have changed nothing, just input lines to the select lines and the enable line to the input line. And remaining all things, all the OR gate, the connections would be the same. So this is the 1x8 Demux for the even parity checker. Up to now we have discussed the decoder as demultiplexer. This is the important point, that demultiplexer can also be used or implemented for the decoder purpose. And we can simply say vice versa is also possible. If you consider that they have given a demultiplexer, so we need to convert or implement as decoder. If you observe, just change the selection lines to the input lines and the input line to the enable line. That's it. Remaining outputs would be the same. So this is the simple thing that I can say. Demultiplexer and decoder can be interchangeably converted or used in a single IC chip. So if you observe, this is the description sheet for the 3x8 decoder / demultiplexer. So this means what this is mean. So in a single IC chip, we can implement the decoder and the demultiplexer at a time. So not at a time. So we can implement both of them. So because we have seen that interchangeably the lines are connected, means we can use anything we want. We can use for the implementation of decoder, or we can use for the demultiplexer. So for this, with the help of single IC, we can use for the both of the purposes. So that is the thing they have given in the official website for the buying of the IC chips. Just for the understanding purpose, we named the variables as S2, S1, S0. But when we come to the digital part, mean the hardware part, it is not like that. We are going to see that as a variable. So as a variable means we can send as anything we want. So for that we can consider as when we are building a decoder, we assume that it is a decoder. When we are building a demultiplexer, we assume that it is a demultiplexer. So that is the thing that I can say. Just those are variables. The inputs, outputs, the enable and the selection lines, those are variables. That's it. Whenever we need, that is the reason we will be going to treat as variables. So I also checked in another website. So if you also observe here, they have written 74138 IC of 3x8 line. We can simply say 3x8 line. So or 3 of 8 lines we can say. So it is used for. So they have directly written the title. They have given the title as demultiplexer decoder IC. So as this is interchangeably converted or used, so that is why they have given this name. So you can also check the price, that is 20 for this IC, single IC chip. I hope you understood the decoder as demultiplexer and demultiplexer as decoder. Both are interchangeably used. So thanks for watching up to now.